Hey there, today I'm going to go through the LeetCode problem 23, merge case sorted lists. And by the way, today I will use my original voice because a lot of my friends said if I use my original voice that will be better. And please don't judge me, and I'm so nervous right now, don't make fun of me. Okay. Here we go. So before the 23, I want to go through the 21 first because 21 is kind of easier. 21 is a merge to sorted list and return a new list. So because we need to merge the two sorted lists, that means we need to traverse the two lists separately and compare their value, right? So right now I'm going to go through the example first. So I have a cursor for the list 1. Let me name this I, and the cursor for list 2. Let me name it J. Okay. So for me, for the linked list problem, for me, every time it need to return a new list or the head of the list will change, I will create a dummy linked list node because I think it's easier for me. So at the same, I will use a dummy node over there. So in that way, I just return my dummy next. Then it's my new list. So let me traverse this example first. So first, I compare the this node 1, which is I point to the first node, and with a J point to the first node. And over here, I will have a dummy node over there. And also, I will have a pointer for my dummy node because I don't want to change my dummy node. I want to, at the last, I will return my dummy.lex. So I will have a list node previous equal to my dummy node. Okay, so I compare the first node, and because they are equal, so I just set my dummy.next is equal to 1. And at the same time, I need to remove the first cursor because I already added in my dummy list, right? Over here, I will have a dummy linked list node. It will have a -1. Right now it's 1. And this is my previous. After I set my dummy.lex equals 1, at the same time, I also need to remove my cursor of the dummy node to this one. And I continue compare the first cursor of my list 1 and the second cursor of my list 2, which one is smaller? Okay, we can say the 1 is smaller than 2, so we add the J cursor point value to the my dummy node next. I mean, not dummy node. Right here it should be the previous node to set it to next. So it should be 1. And and my P pointer should be moved to the next one value, and also the same thing with J. And over here we compare 2 and 3, so 2 is smaller than 3, so we add 2 to my to my previous .next, and remove my pointer for the previous node in the dummy linked list, and move the cursor over here, and we continue compare. The 3 is definitely smaller than 4, so we add 3 over here, and we move the J pointer. I mean, you cannot say the pointer in the linked list, right? It should be the cursor, my bad. So it's the 4 over here. And right now, our pointer, our cursor for the first list is already equal to none over here. So we need to check, at this time, we need to check the second list of this cursor is equal to none or not. Is not equal to none, we just add this node, add this node to my previous .next. Go to 4 over here. Why I say that? Because if for my second list, I have a lot of nodes like this, like 5, 6 over here. This length of this linked list is bigger than my first one, but because it's sorted, we just need to add 4 this nodes to after my previous nodes, so we can directly get the 5 and 7, this new node. So simply we just return the .next, then we return this linked list. Okay, right now we can continue the 23 merge K sorted list, this question right now. So for this question, it's kind of the same. The input is array of a linked list nodes. So since each linked list is already sorted, so we are going to make use of it. So think about how we can make use of these sorted characteristics. So for me, I will think about use the same way with the 21, compare each head of the linked list, and then move the cursor and continue to compare it. So how could I do that? So how about a priority queue? So I implement a priority queue that's named is a minimal heap. Minimal heap. For my minimal heap, I add all the head of each linked list in it. So I give a cursor. For my first list is I, second is J, third is Z. So I put into my minimal heap, but at the same time, I said I will use a dummy node over here because I already get used of it, because I'm afraid the head of list will change. So every time I do the linked list problem, I will set a dummy node. So here is the same thing over here. Dummy node. Okay. And I will go through this example. My dummy node is a -1, and I have a previous pointer for my dummy node. And the things in my minimal heap, I already have a 1, 1, 2. So I just I just get one element from my minimal heap. This is a 1. So I attached it to followed by my dummy node. So in other words, I set my dummy node next to my heap smallest 1 value over here. But at the same time, I will push the next the next value into my smallest, into my minimal heap if that node is not none. So over here I will update my I cursor. So right now it's 4. So I add it to my minimal heap over here, and I get the first one, the smallest one, from my minimal heap. And here, of course, we need to update our previous one. So over here, I put the one after my previous one of my dummy. The previous one over here is the cursor of my dummy node. So every time I need to update it, is the same as the 21 question. So I update the code and I add the cursor j.next into my heap. Is a 3. And then I get a 1 value from my minimal heap is a 2. So added followed by the 1 is followed by 2, and I keep updating my cursor. So updating my cursor, this cursor. So over here should be the 3. I put the 6 in it in my minimal heap, and I got my 3 is the smallest one for now. So I attached over here, attached to the previous .next equal to 3, and update my previous cursor and continue. Here is a 4. This one is a smaller. This one is a equal, this 2. So we can choose one of it. It doesn't matter. Hold on a second. So I missed the last step. So I make up it over here. So get the smallest out and put a 5 in it, and right over here my smallest is still 4. So 4, touch 4 over here, update my cursor, and here is none because the j was pointed to j is none, so we don't have to push into my minimal heap. So, and we compare this one. In my heap, we got the smallest one over here is 5. So I touch the 5 over here, and updating my cursor, point to none as well. and then the last one 6. So we put right now we get all the elements from my minimal heap. So I got them over here. So the heap is already empty, so we finished. So all we need to do right now just return the dummy.next is this list. Okay, so that's it. It's kind of simple. I will attach my codes below, and you guys can take a look. And I will attach my codes below. You guys can take a look, and that's it. Node over here is a 23 solution, and I will show you the 21's code. 21's code is over here. And that's it. That's a question today, and still nervous. And if you wanna give me any advice, please comment it. Thank you so much. See you next time.